In this example, we will use the TI-84 to determine the probability of a sum from a distribution of sums and also to determine a percentile. In a recent study, the mean age of tablet users is 31 years. Suppose the standard deviation is 9 years. The sample size is 50. For part A, what are the mean and standard deviation for the sum of ages of tablet users? What is the distribution? The mean of the sum of ages is equal to the sample size n times the mean of the divisional distribution, which is mu sub x. So we'll say the mean of the sum of ages is mu sub the sum of x is equal to, again, the sample size of 50 times the mean of the distribution, which is 31, which is equal to 1,550 years. And then the standard deviation for the sum of the ages, which we will indicate using sigma sub the sum of x, is equal to the square root of the sample size times the standard deviation of the original distribution, which gives us the square root of 50 times 9, which is equal to 9 square root 50 years. And while this does simplify, we'll go ahead and leave it in this form. And then from the central limit theorem, the distribution of the sum of ages will tend to a normal distribution. And because of this, we can find the following two probabilities using the normal CDF function on the TI-84. For part B, we're asked to find the probability that the sum of the ages is between 1,400 and 1,600, which is the probability that the sum of x is greater than 1,400 and less than 1,600. And now we go to the TI-84, press second vars for the distribution menu, option 2 for normal CDF. The lower bound in this case is going to be 1,400, enter. The upper bound is 1,600, enter. The mean is the mean of the sums, which is 1,550, enter. And sigma is the standard deviation of the sums, which is 9 square root 50. Enter, enter, enter. To 4 decimal places, we have 0.7748, which is equal to 77.48%. For part C, we're asked to find the probability that the sum of the ages is more than 1,625 years, which is the probability the sum of x is greater than 1,625. Going back to the calculator, second vars, option 2. Because we have the sum of x greater than 1,625, the lower bound is 1,625, enter. We need to exaggerate the upper bound. I'm going to use 999,999. Sometimes you'll see scientific notation used here. Enter. Mu and sigma are the same. Enter, 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 and enter again. To 4 decimal places, we have 0.1193, which is equal to 11.93%. For part D, we're asked to find the 75th percentile for the sum of the 50 ages, which will be the sum that is greater than or equal to 75% of the other sums. If we let k equal the 75th percentile, we can state the probability the sum of x is less than k is equal to 0.75. If we look at this normal distribution here, if we say the 75th percentile is, let's say here, where this is k, then the area to the left of k under the curve must equal 0.75. Which also means the area to the right is going to be 0.25, but when using the TI-84 and the inverse norm function, we need the area to the left of k, the percentile we are looking for. So now we go to the calculator, and we press second vars, option 3 for inverse norm. The area is the area to the left, which is 0.75 for the 75th percentile. Mu is the mean of the sums, which is 1,550. Enter. Sigma is the standard deviation of the sums, which is 9 square root 50. Enter, enter, enter. To one decimal place, or the 10th place value, we have 1,592.9. The 75th percentile is 1,592.9 years. I hope you found this helpful.